Well, we're back on the bench again. Time for another project. Something to maybe get us into the spring. I found an interesting article from my youth from Electronics Illustrated 1968. It says, build this bare essentials ham transmitter for under $10. Now, this was published by Ham W5LET, and basically we're talking about a transmitter that is built on a pine board or any other type of board with a single tube. The tube that he decided to use was the 50C5, which is a very common tube used throughout the world. It's equivalent to a HL92 in Europe, and these were typically the output tubes that were used in the main sets, the AC/DC sets of the 1950s that used miniature tubes. Using a single crystal, the transmitter could put out about 5 or 6 watts. There was no transformer. It was operated right off the line. A pretty dangerous situation in this country with 120 volts AC. If one accidentally plugged it in backwards so that the hot and the neutral were switched, or the line and the neutral were switched, if you touch the key and a convenient ground in your station, perhaps a piece of equipment that's grounded like this oscilloscope, you'd get a nasty shock. So he put in one safety device, a neon bulb, and if you plugged it into the wall in reverse, the neon bulb would light up and it would alert you that you were going to electrocute yourself. So this is all interesting, and a few people built this little transmitter on the board and operated it on 80 and on 40 meters. It was a fun little project, but of course more or less just a toy and not something that people took very seriously. This got me thinking, perhaps this circuit could be built in a European or a world setting where we have 220 or 230 volts AC with 50 hertz. Wondering if this transmitter could not be adapted to operate on ordinary 220 house current. So this is what we're going to attempt to do. We're going to attempt to remake the circuit. And it's a very simple circuit, by the way. Only about 15 or 20 components. Let me show you his original schematic. This is the original schematic with the 117 volts or the 120 volts AC. I'm going to use a pointer here. We have a half-wave voltage doubler, which takes the 120 and steps it up to double the peak power, or around 300 volts DC for the 50C5 tube. It's a simple crystal oscillator feeding the antenna, and the key, which simply grounds the cathode. And here's his safety device, the neon lamp, going to a water pipe ground or some other type of ground in the house. If this should come on, you need to reverse the line and the neutral on the input. And here's where the key attaches. So we're attempting to build an off-the-line powered ham transmitter that can work in the 40 or the 80 meter band for a CW transmission. We're hoping to get about 5 watts out of this transmitter. It uses a common tube used in the output circuit of AC/DC sets of the 1950s, namely the 50C5 tube. Now, the first thing we're going to do is look at the original layout that was envisioned in the 1968 article. It's a pretty logical layout. He's got the power coming in one side. He's got the safety neon lamp and the ground circuit here. He's got the output to the antenna and the output tank coil up in the upper left. and down here we have the key. This is not a bad layout. I think we can stick with something like this. Okay, let's talk about what we have to do to the basic W5 LET transmitter to make it acceptable for a 220, 230 volt, 50 hertz transmitter. First of all, we know that we've got 220 coming in, and we're trying to illuminate the filament of a 50 volt tube. So we've got to drop that voltage, so the resistor that feeds the filament of the tube is going to get a little bit bigger. Second of all, since we already have 220 volts to start with, we don't need to use a voltage doubler. We can use a straight half-wave rectifier. And I'm taking the two capacitors, leaving them in, and putting a resistor between them to make a pi filter. So that's essentially the only changes that I'm going to make. The warning lamp, of course, for 220 needs to have a little bit larger dropping resistor, so I've doubled that to 220K. So this comprises the basic modifications of the transmitter in order to run it on 220, 230 volts, 50 hertz. Again, this is the basic transmitter with no real modifications other than the power supply switch, so it'll accommodate the 220. The power resistor is going to be close to you, and we know this is going to be a pretty hot, physically a pretty hot device. So we want to make sure that's in a place where we're not accidentally going to come against it. We might even want to make a guard for that. So I will start to construct the transmitter now, and I'm going to stick with his method, which is to use the small finishing nails. This ought to be interesting to see how I can solder to this. By the way, if you are soldering to finishing nails, you're going to need a pretty hot soldering iron or a soldering pistol. Okay, here's where we talk about affording a project like this. And I know there's a lot of people around the world that have had trouble getting a hold of parts that are economical. Some of these parts have gone right through the roof as far as the price is concerned. It's hard to get these parts. But I wanted to do a little exercise. The original article claimed that you could build this Bare Essentials transmitter for less than $10, under $10. Now those are $1968, and I looked it up, and $1968 equate to $68 in 2014, or approximately 50 euro, or 50 dinars if you're in Jordan, or 200 zloty, okay? So that's our budget to stay under the $10. So the next thing I did, I took out the things that I think we can get very easily that we're not going to put on the price list, such as the board, the AC cord, the key, any wire we might need, the pill bottle, that kind of thing. And I just have on this list the small parts that we would need to build the project. I went on to eBay. I found some international sellers of various components, included the shipping cost, and here's what I came up for prices for the salient parts for this project. 3 ceramic disc capacitors, $3.35 US, 1 trimmer, $6, electrolytic capacitors, $4.50 for the pair, a neon lamp, $5, half-watt resistors, $4, wire wound resistors, $9.50, 2-watt resistors, $6, crystal, $16 US just for the crystal. Now, if you were to use a color burst crystal like this, you could probably pick that up for less than £1. Don't try to use these little tiny crystals because I think the tube would cause too much heating in them. The thing would chirp like a bird. The diode rectifier, $1, and the 50C5 valve, $12.50. You add all of that up, and it comes out to $67.98, exactly the $68 that equates to $10 in 1968. So I know you guys are going to say you're absolutely out of your mind, but I want to tell you, $10 is $10, and that's how much this thing is worth. So here we have a single octal tube socket that's accommodating 2 crystals, so that makes a very nifty crystal socket. If we were to break this socket apart and remove the contacts, we could put the contacts directly on the board and plug the crystal directly into the board. The circuit calls out for coils. That's cut off, makes a nice coil form. Piece of PVC pipe. If you're lucky enough to have plug-in coils, you could have a plug-in coil arrangement where you could have an 80 or a 40 meter transmitter. You could use some stiff cardboard. These work out really well if you can soak them in a little bit of varnish or polyurethane, and you can get a nice high Q coil using cardboard. Let's talk about the tubes. I mentioned that this works with the 50C5 tube. I see a 50 Baker 5, a 50 B5 tube, a 50 EH5, and finally the European HL92. These are all essentially the same output tube, and all would work very well in this transmitter. Tube sockets. Hopefully you can find some tube sockets in your junk box. These are all miniature type 7-pin tube sockets. And mounting the socket, we could probably find some standoffs. Here's a couple of standoffs. I can mount this socket on the board with the standoffs and a couple of screws down through the standoffs. That would be very deluxe. I could just take this and put a single nail through the middle of it, and that would comprise mounting the socket. You don't have to have anything too elaborate to mount the tube socket. Everybody complains we can't get our hands on variable capacitors. These are like hen's teeth trying to find them overseas. Okay, if you can't find them, why not make them? A homemade patter capacitor or trimmer capacitor simply made out of a couple of sheets of flashing. I use steel flashing. This is a 15-cent piece of steel flashing that you use in your gutters up near your roof edge. I simply cut it out, drilled a few holes, wrapped some scotch tape around both sides, and I have a nice effective trimmer to tune the coil on the outputs. In the original article, he called for disc capacitors. These are ceramic disc capacitors, cut out of old radios. If you have tubular capacitors, paper capacitors, these will all work in this circuit. Modern mylar capacitors and polystyrene capacitors will all work. Electrolytics used to be pretty large. Now they've gotten very small. Now getting from 220 volts down to 50 volts takes a lot more voltage drop than going from 110 volts down to 50 volts. So the dropping resistor becomes quite large. If you do the math, 230 volts minus 50 divided by the current that you need to light up the tube, which is 150 milliamps, it comes out to a 1.2K or a 1200 ohm wire wound resistor. What's more important though is that the resistor dissipates 27 watts. 27 watts. So now we have to be a little bit careful with our resistors. We're not going to use small resistors like this 2 watt. These will burn up. You've got to use power resistors like this. One way to handle this situation is to buy 2 power resistors, each with 25 watts, let's say. That will give you 50 watts total dissipation. And thread them through a rod like this. If you really want to get fancy, get some metal and bend up some standoff material and mount the resistors between those standoffs. Now this not only gets the resistors up off the board, it improves the dissipation of the resistors and certainly gives a much safer situation on the board. The 27 watts will be dissipated without causing any trouble with an arrangement like this. You can also find some brackets that are ready-made, or you can make brackets that actually insert into these resistors, and they hold the resistors similarly. Okay, next we have to start to talk about our construction technique. Now, we have our board, and this could be any kind of board, but I suggest pine because pine is soft. It's easy to nail or screw fasteners into it. So, in the original article, he suggested using finishing nails. Finishing nails are steel nails that are used to put furniture together, and they have a very small head on them. You can solder to these, and you can continue to use the simple finishing nails as the construction technique. You could also use brass brads. You're going to have better junk boxes than others, and you're going to have more access to better electronic components. For instance, you may have access to terminal strips. If you do, building this with terminal strips with screws would be a much better method than using the brads or the tacks or the nails. Also, some of you might have access to jacks for the key. The key goes into the jack. In the original article, he simply soldered the key, which was some lamp cord, directly to the transmitter, so it was one connection. But if you have access to a jack, bend up some metal, make yourself a little front panel, and mount the jack to it. An SO239 connector that will go right to the coax of the antenna. You can nail this right to the back of the board with one screw. You could put a little piece of metal and make a bracket for it. That would make a neat antenna connector. Resistors, which could be used for the tuning rather than using the trimmer that we showed you. And you might even have access to a nice plate meter that could measure your plate current. Okay, coil winding. Now, when you're winding the coil for 80 or 40 meters, make sure you have the primary turns closely spaced and neat. Usually drill 2 holes, 2 at the top and 2 at the bottom, and run the magnet wire through them, the enameled wire through them, so that we get a nice tight wind. The output link is heavier wire, and notice how it's towards the bottom or the ground or the cold end of the tank. As you raise this up, your coupling becomes tighter. So bringing the 3-turn output link down is less loading, bringing it up is more loading. You'll find an ideal place where you get the best output coincident with the best keying of the transmitter. So we're attempting to build an off-the-line powered ham transmitter that can work in the 40 or the 80 meter band for a CW transmission. We're hoping to get about 5 watts out of this transmitter. It uses a common tube used in the output circuit of AC-DC sets of the 1950s, namely the 50C5 tube. In the next video, we're going to go over the construction and the safety aspects of the transmitter. We'll begin to put parts down on the board.